Hello, this is my walkthrough video for my programming assignment number 5. I'm going to start out by walking through all of the commands in Appendix A. Great. Let's run the program. Here's the status of all the hospitals. Right. There's the updated status. Right. Right. There's part 1.
Okay, so for part 2, I switched over to Visual Studio just to use the debugger, and I'm going to walk through my process command function to show how my code is processing the emergency command. Okay, so I hit enter, and now we're just going to step through this command right here. Alright, so we take in the string as a parameter. And then firstly, we're going to check if the user is quitting or exiting before anything else is done. And this conditional right here is true because it is an emergency. And this right here is where the parsing happens. Alright. And I did enter a valid severity, so this conditional is not going to be true, and we're going to go into this handle emergency function, which is going to take the name, severity, and city. And then we're going to use the Dijkstra's algorithm. Okay, we're going to create a patient using my patient class and the constructor right here. Right, and right now I'm just pushing the node or the patient onto the graph. Okay. Now, hopefully I didn't go too far. I'm going to try to run the status command. Oh. I go back up a line. There we go. Right. And I did enter Pullman as the city for that patient, so it looks like this patient did get sent to the Pullman hospital, and they're waiting in the queue. So for the time complexity of the insertion operation, it is going to be big O of log n, because after the patient is inserted, the heapify up function is run, and that, at worst case scenario, takes big O of log n. As for my merge screw function, on average, the time complexity is big O of log n as well. However, the worst case scenario is time complexity big O of n. Alright, real quick I'll try that again, but I'm actually going to walk through the the shortest path function. Okay. I'm not debugging. Wow. Okay, let's create the patient using the strings inputted by the user. Now we're going to have to find the nearest open hospital, and eventually, alright, so we're going to go through my shortest path Dijkstra's function, and by the end of this, we're going to figure out that Moscow is the closest city after Pullman. Okay, so we set the distance from starting node to starting node equal to 0, and then we're going to initialize the priority queue and push the first node to it. Oh. Okay. Okay, so my debugger was having issues reading a specific line, but I rewrote it, and it should work properly now. Alright, I'm just going to keep stepping until I get to my Dijkstra's algorithm. There we go. Just initializing my vectors, making the priority queue, and then pushing the starting node. Okay, and this is going to run until our priority queue is empty, and by the end of it, we're going to have the index of the next closest node returned by this function. Okay, looks like we were able to push the node, or the patient, onto the graph, and it should have printed out that the patient was admitted to Moscow. Yeah, there we go. Okay, perfect. There we go. Okay, for part 3 of this video, we're going to take a look at how my program is handling closing a hospital, and I'm just going to walk through that with the debugger. Okay, we're going to get an integer to represent the city ID. Okay, first we're going to check if this hospital is even open in the first place in order to close it. Okay, then we're going to set this hospital node's ID dot open boolean equal to false. Okay, there we go. We closed the Pullman Hospital, and there were no patients there, so there were no patients to transfer. Also, I'm going to run the function after a patient has been admitted to Pullman. Okay, actually, I don't want to do that. Okay, there we go. Now I'm going to close Pullman Hospital. I believe I still have a breakpoint. There we go. Now this should find the shortest path and determine that the patient needs to be transferred over to Moscow. Okay, here we go. I'll just walk through this really quickly. Okay, there we go. Alright, for part 4 of this video, I'll show how my code is finding the highest priority patient when I use the treat command. So let me find a good spot to put a breakpoint. Here we go. Okay, I'll show the status before the function. We have one patient waiting in Pullman. Now, we'll treat the top priority patient in Pullman. Looks like we hit our breakpoint. Now we're taking in the name of the city as a string. Oops. Now we're checking whether or not that specific hospital is open. And right here, this condition is checking if there are any patients in that city that need to be treated. Or checking if it's empty, rather, and if it were to be empty, we would return and get out of this function before doing anything else. Now we're just popping the one patient that's in that priority queue. And if there were to be more patients, then the next patient with the highest priority would be now the root patient after this most recent patient was popped. Okay, there we go. That patient has been treated. As for the time complexity of my handle treat function, after the patient is popped, the heapify down function is called, and that is big O of log n. Okay, so lastly, for part 5 of this video, I'm going to show how my graph and shortest path implementations work, and we'll start at this breakpoint right here. So right now, we're initializing the graph with an adjacency list, and we're going to pass in the number of vertices. So the number of vertices we're using is 5. As you can see, 5 cities have been initialized up here. And for each city, we're going to give it 2 edges, both with certain weights. And this process will continue until we have a full completed graph. Okay, and right here is the section of code that's updating the distances using Dijkstra's algorithm inside of my graph. I'll just put a breakpoint right here. And at the same time, I'm also going to show what happens when my program tries to admit a patient to a hospital that's closed. So let's start out by closing a hospital. Jeez. Okay, now let's make an emergency in Pullman again. And we reach our breakpoint right here. And this loop is going to continuously update our distances until it finds the shortest one. And once it does, the index of the city will be returned. The city, which is the closest distance away from Pullman, which, like I showed before, is Moscow. So right here, we are continuously updating the distances until we find the shortest possible one with a hospital that's open. Okay, there we go. And finally, for the space and time complexity of my shortest path Dijkstra's algorithm, my time complexity is O of the amount of edges times log the amount of vertices. And for my space complexity, it's just the amount of it's the amount of vertices and edges together. So big O of vertices plus edges.